Hey, welcome to Linode. My name is Austin Gill, and I am fortunate enough to live in a neighborhood with about a bajillion dogs. And just down the street from me is a park, which is also fortunate because that means I get to say hi to all these dogs as they walk by to go to the park. The only problem with this is that we have so many that it's getting hard for me to remember all of their names, let alone the owners' names, which has been awkward. So anyway, I thought it would be cool to make a video series where we get to work on an application together and build out a solution to my problem. It'll be some tool that we can use to capture the details of each pet, including the name and the type, maybe the birthday in case we want to give them a surprise. And we should be able to browse through all of the pets as well as modify some of the details if we need to. So you can think of it as a pet relationship manager or PRM, or maybe we can come up with a better name like neighborhood pet manager. That way we can call it NPM. Now we could build this in a number of different ways, but for this project, we'll be using Remix, Prisma, and a SQL database. It's okay if you aren't familiar with these tools right now, but you should have a fundamental understanding of HTML, JavaScript, probably React. This is not going to be a Web Development 101 course. So I hope that sounds interesting to you, and I'm going to start with a short overview of the project. So first and foremost, I want to answer the question, why are we using SQL database? Well, firstly, in our application, we're going to need to perform all of the common CRUD operations on our data, and that stands for create, read, update, and delete. Now, while we technically could do all of these operations on an in-memory data store or on a JSON file, this is really what databases are built for and where they shine. So while databases are awesome, we can't build an application with just a database. We need something to visualize the data, and that's where Remix comes in. Remix is a full-stack web framework that runs on JavaScript and supports both server-side rendering and client-side rendering, and it's pretty awesome. Currently, it uses React as the templating engine. I've also got the project set up with Tailwind for styling, as well as some pre-built components, so we shouldn't have to write too much from scratch, which is great because it allows us some time to focus just on the things that make Remix unique. So now we've talked about the database and we've talked about the application UI, and the only missing piece of the puzzle is the connection between the two. And although we could use some software that lets us write raw SQL queries and send them to the database, in many cases, an ORM is going to be a lot faster, safer, and easier to use. So today we'll be using an ORM called Prisma, which is an awesome tool with a lot of great features, including really good TypeScript support, nested query support, migrations, transactions, all of these things that may or may not make sense right now, but hopefully they'll be more obvious when we get into the code. And before we get too far along, you want to make sure you have all the necessary software installed on your computer. This includes Git, which you can find at git-scm.com, and Node.js, which you can find at nodejs.org. You'll also want some sort of code editor. I personally prefer Visual Studio Code, which you can find at code.visualstudio.com. And lastly, and optionally, you may want to install a database visualizer so you can actually see the data in your database. Now, I personally like dbeaver, which you can find at dbeaver.io, or if you're using VS Code, there's a really cool extension called Database Client for VS Code. With the required software installed, you should be able to git clone the repository into your target workspace. Once the clone is completed, you can cd into that workspace and npm install all of the dependencies. So with all of our projects set up correctly, we can open up the project in our favorite code editor. I'll be using VS Code, and we can explore the project. So up at the top, we can see an app folder, and this is where all of the sort of source code or logic for Remix lives. We have some components, we have some layouts, we have some routes, we have some services for any sort of external or third-party dependencies, and some styles, and then a few files in the root of the application. Now, the name of this folder does matter because this is the default name that the Remix CLI will look for to serve your application. Next, we have the node modules folder. This is where all of our NPM dependencies have been installed to. Then we have a Prisma folder, and this folder contains all of the configuration logic for Prisma. Next, there's the public folder. This is also kind of Remix related, and it will contain any sort of static assets that are not going to be running through the build pipeline, but need to be included in the final build. And then in the root, we have several configuration files, which I'm not going to focus too much on, but I will look at the package.json file. Specifically, I want to look at these scripts. So we have a couple of dev scripts and a couple of build scripts and a start script. The start script is going to be used to run the production environment. The build scripts are going to be used to build the production artifacts, and the dev scripts are the one that we're going to focus on most, and those are the ones that run when we want to go in development mode. Particularly, this dev command is going to execute the concurrently package to run both of these commands at the same time. So we have the dev CSS, which is going to run our Tailwind build and watch for file changes. And we have the remix dev, which is going to run the remix CLI and look for file changes in our app folder. The next step before we can actually get development going is to configure Prisma to work with our database. For that, we'll go into the Prisma folder in the project and open up the schema.prisma file. Now this file tells the Prisma CLI a couple of things. First, it has a generator that tells the Prisma CLI to build a Prisma client, which we'll look at later on. Next, it highlights the data source for the database. In our case, we're telling Prisma that we're using a Postgres database, and the URL to connect that database is this interesting string here. Now, this is a function that is used by the CLI to inject the database URL from the environment variables when it runs through here at build time. And we want to use a function that dynamically injects that instead of hard coding those values, because if we were to put our production database connection string here, then anyone that has access to this code base would also have access to the database. So it's much safer to use an environment variable, because then we can give access rights to the right people based on development environment or staging environment or production environment. So there's a number of ways to add environment variables to our environments, and fortunately, both Prisma and Remix both use the same convention of relying on a .env file to inject variables at runtime. So we can take this env sample file and we can paste it, and we can rename it to a file called just .env. In this case, both Prisma and Remix will look for this environment variable file, or this .env file, and pull the values at runtime that are in here. So this file is not going to be tracked in GitHub. In fact, it's in the git ignore file, because you don't want to put your environment variables in your version control. Now, because I'm going to be using this env file to only define local variables, I'm going to set it up for local development. So I'm going to set the node env to development, and I'm going to change the database URL to connect to my local Postgres database. So we'll use the Postgres protocol. I will set the username to Postgres. After all, that's the default. I'll set the password to just password. I'll change the domain to localhost. I'll leave the port at 5432, and we'll change the database to Postgres as well. I think those are the default values that I had originally set up. And with that, now Prisma will be able to connect to my local running Postgres instance. Now this all assumes that you have the Postgres software installed and running and configured correctly, and that may not be the case. So I'll give you an alternative. Firstly, if you're comfortable with Docker and you have that installed on your computer, we can use that to run a local Postgres database on our machine. Docker run in detached mode. I'm going to give mine a name of npm, sure. And we're going to map the ports from 5432 on the Docker container to 5432 on the host machine. And I'm going to set the environment variable of Postgres underscore password to match the password I had in my environment variables. And I'm going to tell Docker to use the official Postgres image. Now, I didn't actually execute that because I already have it running locally and it can take a while. but if you want to run it locally, that should work for you. Now let's say that you don't have Postgres installed locally and you don't have Docker, and those are just two words that you've never even heard of. That's still okay. We can actually use a different database called SQLite, which is based purely on the file system, and you don't have to install any other software for it. So back in our schema.prisma file, we can change the Postgres provider to SQLite. And like I said, you don't have to install anything else, but we do need to modify the environment variable database URL. We're going to change that from the Postgres protocol to just file, and then we'll change that to ./dev.db. And that's going to tell SQLite where to store the database file relative to the schema.prisma file. So it's going to eventually live in this Prisma folder. Now, the only thing that's missing from our schema here is telling Prisma what our database actually looks like. So we can't have a database without any tables. It wouldn't be very helpful. So we're going to create some, and in Prisma world, that's going to be defined by a model. So we're going to say we want a model, and we're going to be managing pets. So we'll call our model pet, and then we'll add some definition to that model. Firstly, a common convention across objects in your database is they're all going to want to have an ID. Now in our case, we're going to make ours a string, and I'm going to mark it with the ID flag to tell Prisma that this is the unique identifier for this entity. Next, I'm also going to tell Prisma that I want to use a default value, so I don't actually have to provide the ID when I create a pet. I want it to automatically inject one. And I'm going to use a function called CUID, which is a unique identifier that is short and URL friendly. Next, we said that all of our pets are going to have a name, and that's also going to be a string. And all of our pets are also going to have a type, for example, dog, cat, fish, lizard, whatever. That's also going to be a string. Next, we also probably want to know the age of all of the pets, but it doesn't make sense to store that as a number because that age is going to change every year. So instead, we're going to store the birthday, and that's going to be a date time. Now, this is going to be slightly different than the name and the type, not just in the type of entry it is, but in that it's not really a required field. After all, if we meet a pet and we get its name and we know what type it is by looking at it, we may not feel comfortable asking the birthday, or we may have forgotten. So I'm going to go ahead and mark that as an optional field. And in Prisma, the optional flag is defined by a question mark after the type. Next, I'm going to add two more properties, which are going to follow other common database architecture design decisions. So one is having a field called created at, because you may want to query by which one is oldest or newest. That's also going to be a date time. And I'm going to mark that with another default value using another function called now. And that's basically just going to fill in when this is created, it's going to put the value automatically of whatever the current time is. I'm also going to add the updated at in case we want to know when something was most recently modified. It's also going to be a date time, and I'm going to give it the flag of updated at. And once again, that's going to be a field that is automatically injected whenever we make an update to that data or to that entity. So we don't have to manage those. The only things we're going to have to manage manually are the name, the type, and the birthday. So back in our terminal, we can use the npx command, which should be available through npm, and we can use that to call the Prisma CLI with a migrate command. Now the migrate command is necessary anytime that we make a change to our schema.prisma file, because that's effectively telling Prisma, hey, we've made a change to this file, and we want to make sure that we are in sync with the actual database that our data lives in. Now, in some cases, we may actually want to check and see that there are differences and what those differences are. So we can use this dev command to essentially check a difference between the deployed database and a local shadow database that Prisma is going to run for us. Now let's see what this does. So we get a couple comments out here. We say that the environment variables are being loaded from the .env file. It tells us that it knows where our schema.prisma file exists, and it's going to say that it uses SQLite to create the dev database at the dev.db file where we told it. Next, it's going to ask us for a name for this migration. Now this migration, we want to have a name for it so we know what's going on. So I'm going to call it something like init, because this is the very first migration. Next, we can see that it created the following migration files, and it ran some generators, and it created our Prisma client for us. Again, we're going to look at this a bit later. But for now, I wanted to look at the changes that we see in our code base. We can see now in our Prisma folder that we have the dev.db file, which is a SQLite database, and the dev.db journal. We can also see that we have this migrations folder. Now inside of this migrations folder, we have this other folder with a timestamp and the init comment that we made earlier. And this is really cool, because if we open this migration.sql file inside of that folder, we can see the actual SQL that Prisma ran in order to create our database. And if we compare that to our schema.prisma file, we can see that we have our model pet here corresponds to the SQL here. We're creating a table called pet, which matches our model. It's going to have several columns, including the ID, which cannot be null and represents the primary key. It's going to have a name, which cannot be null, a type, which cannot be null, a birthday, which can be null, aka optional. And then it's going to have the created at and updated at fields, which are both going to be date times that cannot be null. Now, this was an example of how it would look if we ran that with a SQLite database. And of course, I'm going to be using my Postgres database running inside of Docker for the rest of this series. So I'm going to go back and undo this migration. So I need to change this SQLite to Postgres, and I need to return my env to my Postgres connection string for my local instance. And I'm going to run that migration command one more time. And this time we get a similar string of text printed to the terminal, except the database source is now Postgres. So for this migration, it's also asking me for a name. I'm going to call it init once again. And then it generates the migration files and the Prisma client. And so now if we look at the project again, we still see that migrations folder, but we don't see the local database. We do see this timestamped folder, and we see the migration.sql file. And this time we see a slightly different syntax for the SQL that's being generated. And this is very important because the Prisma team highly recommends using the same database provider that you're going to be using in production. And that makes sense. After all, you want your local development environment to match as closely as possible to your staging environment, which is also going to match as closely as possible to your production environment. So using SQLite could actually behave slightly differently. And we can see in the documentation that there are some features that are not supported in SQLite that are supported in Postgres. So if you can use Postgres, I would highly encourage you. If you have to use SQLite, that's okay. You can do it for local development to begin with, but once we launched into production, it's going to be much more difficult to go back to SQLite. Now, if you're not comfortable using a local Postgres instance or a local Docker environment, you can reach for a managed database solution like the one provided by Linode. If you don't have an account, you can use a link in the description to create a new account, and you'll get $100 credit for 60 days. So you can try, that's plenty enough to give it a try and see how you like it. And once you set up a new database, Linode will give you the connection string that you can use in your environment variable file so that you'll be able to connect. Now, ultimately, when we get to the production deployment, I'm going to be using Linode's managed databases anyway, but it's nice in development to use something local because that will reduce the amount of time you spend waiting on that network latency. Either way, there's plenty of options for us to get started, and we should be able to move forward. So now that we finally have everything installed and connected and configured, we can get on to actually building the application. So let's go to our terminal and type in npm run dev. That's going to be the dev command to get concurrently running our Tailwind process and watch for file changes and our Remix dev server up and running. And that's going to eventually get started at localhost 3000. So now if we go in our browser to localhost 3000, we should see a very basic application that just says hello world and has a nice cute background. So one last thing that I wanted to show you is inside of our app folder where we are using our services to access the Prisma client, I did configure our Prisma client to with this log command. Now this log command is going to be assigned to either an array with query as a string or an empty array, and that is going to be based on the environment variable of node_env. So because we have set our environment variable locally in local development to development, this is going to assign the log property to log all of the queries. And the only reason I bring this up is because we'll be able to see in our terminal, as we get requests and start using Prisma, we'll be able to see that the SQL that Prisma is generating is being printed to the console. And this is a really handy way to make sure that what you intended Prisma to do is what it's actually doing, or that what Prisma is doing is something that you can read and kind of learn some SQL at the same time. So I thought it was worth pointing that out. So thanks for watching this sort of introduction overview video. And once again, if you are new to Linode and you want to check out some of the products, including compute products or the managed database, you can hit that link in the description to sign up for a new account, and you'll get $100 of credit to check everything out in the first 60 days. So be sure to like this video and subscribe if you want to be notified when the next video comes out, where we actually start digging into building the application in Remix.